I'm Poonam Sharma, your science teacher. Welcome you again another session of acid, bases and salt chapter. In previous classes, I have already explained about acids, their properties, bases, their physical and chemical properties, and I have also elaborated types of salts. Now, in previous class, I've discussed preparation of few salts, their uses, and how can we use them on a daily basis. Now, in today's class, I'll continue with some other important salts, their preparation and their properties and uses also. So now, next very important salt is baking soda, and the chemical name of this baking soda is sodium hydrogen carbonate. As you can see, sodium hydrogen carbonate, due to the presence of hydrogen and carbonate, it is named as sodium hydrogen carbonate. This is the chemical name, and common name is baking soda. We use this baking soda as an anti-acid also because it neutralizes the effect of acid. It is a strong base. Now, how this baking soda is prepared? Baking soda is prepared by the action of brine solution. Brine means when sodium chloride dissolves in water, it becomes a brine solution. So when brine combines with carbon dioxide and ammonia, and this entire process is known as solvay process. When brine combines with carbon dioxide and ammonia, then this is known as solvay process, which results in the formation of ammonium chloride and sodium hydrogen carbonate, which is a baking soda. We use baking soda as an antacid, and as you can see here, this carbon dioxide gas combines with this, it becomes carbonate, and chlorine combined with this ammonia, it becomes ammonium chloride. And the name of process is solvay process. Now, there are certain properties of sodium bicarbonate. It is white crystalline solid, but it exists in a very fine powder form. And it is amphoteric in nature. It means it has property of both metals and non-metals. Then it is sparingly soluble in water. It means if you dissolve it, it will not completely dissolve in water. So for this completely dissolution of sodium bicarbonate in water, we need to apply some heat. So that is known as thermal decomposition. So after thermal decomposition, we can dissolve sodium hydrogen carbonate into water. Then when baking soda is heated, when we provide heat, it decomposes into sodium carbonate, and carbon dioxide gas is evolved and plus water. Due to the evolution of this carbon dioxide gas, it makes the substances fluffy. That's why we are using it in making cakes and bakery products. Due to the evolution of this carbon dioxide gas, it makes the cakes and pastries very fluffy. So when we heat, it forms sodium carbonate, which is baking powder. I'll discuss this in detail later. Now, sodium carbonate formed after thermal decomposition. It means when we provide heat, so we get sodium carbonate. And if we further heat this sodium carbonate, we get sodium oxide and carbon dioxide gas. This process is known as dehydration reaction. So these are the different reactions when we heat sodium bicarbonate. Now, next is, what type of question can come on this topic? Like, why is sodium hydrogen carbonate an essential ingredient in antacids? The sodium hydrogen carbonate we use as an antacid because of its basic property. Because it's a basic type of salt in which strong base and weak acid is involved in its preparation. So it neutralizes the effect of HCl, which is produced in our stomach. So that's why we use sodium hydrogen carbonate as a basic ingredient in antacids. As you can see here, this is sodium hydrogen carbonate. When it combines with HCl, it gives NaCl, water and carbon dioxide gas. Now next question can come in the exam is, what is baking soda chemically called? It means you need to give the chemical name of baking soda. Give reaction involved in its preparation, write one of its uses. And chemical name of baking soda is sodium hydrogen carbonate, which I have already discussed with you. And what is the preparation, what is the reaction involved in its preparation is, so you need to write the entire equation, NH3, that is ammonia plus carbon dioxide gas, or H2O plus NaCl, which is known as brine. So when it combines, and this is known as solvay process. This is known as solvay process. Remember, 1 mark question can come, name the process which is involved in the preparation of baking soda. And the answer is solvay process, which results in the formation of sodium hydrogen carbonate and ammonium chloride is released. So if and when we get this sodium hydrogen carbonate, so this is used as an antacid. And if we heat or we combine sodium carbonate with carbon dioxide and water, in return we will get sodium hydrogen carbonate again. This is baking soda and this is baking powder. This is baking powder. Now this is how baking soda is chemically prepared. So you can write any of the method, both are correct one. But if it is clearly mentioned in the question, how can we prepare baking soda by using solvay process? So in that case, you'll write this equation. Then don't write this. If it is not mentioned, then you can write any of the reaction. Now what are the uses of baking soda? As I told you, this baking soda is used in the preparation of baking powder. When we heat it, so it decomposes by thermal decomposition method and it converts into baking powder. So which is used in cooking. When it produces carbon dioxide gas, it makes the batter soft and spongy. Then baking soda is used as an antacid in case of acidity. It is used in toothpaste, being a strong basic in nature. So it removes the acidity in our mouth also. It neutralizes rather the effect of acid in our mouth. And it is used in the cleansing of ornaments made of silver. So if silver gets oxidized, some black color layer deposits on it, which is due to the reaction between silver and oxygen. So if we want to remove that silver oxide layer, we use this baking soda. Then sodium hydrogen carbonate gives carbon dioxide gas and sodium oxide on strong heating. It is used as a fire extinguisher. Due to the evolution of carbon dioxide gas, this carbon dioxide gas blocks the supply of oxygen, because oxygen is considered to be a good supporter of combustion. So to block the supply of oxygen, we need carbon dioxide gas, and that's why we use this baking soda in the preparation of fire extinguishers. So when we apply fire extinguishers, so this carbon dioxide gas makes a layer and it does not allow the oxygen to come in contact with that fire and fire gets extinguished. So these are the uses of baking soda. Then we have baking powder. As I told you, baking powder is formed as a result of the heating or thermal decomposition of baking soda. So when we heat baking soda, or we call it sodium hydrogen carbonate, we'll get sodium carbonate. Along with this, it results in the evolution of carbon dioxide and water. So when we heat this sodium hydrogen carbonate, we'll get sodium carbonate and carbon dioxide gas and water is released. This baking powder It is a mixture of baking soda and a mild edible acid. Edible acid here means which we can consume. So generally we use tartaric acid in its preparation because it removes the bitterness of the sodium carbonate. That's why we are adding tartaric acid, because it removes the bitter taste due to the formation of sodium carbonate. It's a 2-mark question and it's a reasoning question. Why we add tartaric acid in when we are making this bread and cake? So tartaric acid helps to remove bitter due to the formation of sodium carbonate. So this is how baking powder is formed. Now what are its properties? Let's discuss. If we heat this baking powder or if we heat baking soda, there are certain properties. First is action of heat. Action of heat. These are very important questions. These are properties of baking soda. If NaHCO3, this is sodium hydrogen carbonate. If we provide heat to this, then it converts into Na2CO3 plus it results in the formation of water and carbon dioxide gases evolve. So this is the action of heat on sodium hydrogen carbonate. This is first property. Then it is empathetic, as I told you. Next is if it reacts with acid, NaHCO3, when it reacts with HCl, dilute HCl, then it results in the formation of NaCl. NaCl, this Na combines with the Cl plus H2O plus again carbon dioxide gases evolve. So these are the properties of sodium hydrogen carbonate. When heat is there, when we provide heat, it converts into sodium carbonate plus it results in the formation of water and carbon dioxide gases evolve, and due to the evolution of this carbon dioxide gas, it makes the bread and the cakes fluffy in nature. And if we react sodium hydrogen carbonate or baking soda with dilute HCl, it results in the formation of sodium chloride, water, and again carbon dioxide gases evolve. And we add tartaric acid to remove the bitterness due to the formation of this sodium carbonate, which is baking powder. Next is washing soda. And washing soda, which is also known as sodium carbonate. Now how this washing soda, sodium carbonate, is prepared? This washing soda, we use this sodium carbonate in our daily life in washing clothes, and it removes the permanent hardness of water. So this is a very important ingredient in our daily life, and how this is prepared chemically. This is extremely important topic, how we prepare washing soda. Washing soda is prepared by a solvay process. Again, as you can see, if I just show you this one. This one, sodium carbonate. So if we use, look at this reaction. Here we have taken sodium chloride, carbon dioxide, ammonia and water. Again we have taken brine here. So if this brine is when sodium chloride dissolves in water, we call it brine. So in the presence of brine, if we are using ammonia and carbon dioxide gas, it results in the formation of ammonium chloride and sodium bicarbonate. Again the same reaction which we use in the making of sodium hydrogen carbonate, baking soda. So when we heat this sodium carbonate, and this is known as solvay process. This we have already discussed. So raw materials which we are using in the preparation of washing soda are ammonia, calcium carbonate, water, and sodium chloride. So these are the things which we are using in its preparation. And here you can see when we heat this sodium hydrogen carbonate, it results in the formation of sodium carbonate. Sodium carbonate. Here you can see, and carbon dioxide and water is released. This sodium carbonate, which is anhydrous salt. Here anhydrous salt means salt which do not contain water in it. That kind of salt is known as anhydrous salt. So we'll get sodium carbonate, which is anhydrous salt. And when this sodium carbonate combines with 10 molecules of water, it results in the formation of sodium carbonate decahydrate. Decahydrate. Deca means 10. It means it contains 10 molecules of water. So when sodium carbonate, which we get as a result of the heating of sodium bicarbonate, and if we mix up with water molecules, it results in the formation of sodium carbonate or decahydrate, which is a washing soda. And here hydrated is written, it means it contains fixed amount of or some molecules of water. So that's why we have written hydrated here. And anhydrous means salts which do not contain water molecules in them. An example is sodium carbonate, NaCl. These are the examples of anhydrous salt. Now what are the actions of washing soda on air? If we leave this washing soda and it comes in contact with air, then it loses its water molecules. When washing soda first is comes in contact action of air, first I'll write action of air. So if we leave washing soda in air, it loses its water molecules and it becomes anhydrous again. So how we write the reaction? Now look here, Na2CO3 10H2O. So when we exposed in air, it loses its water molecule and it becomes sodium carbonate again, and it loses 9 of its molecule, 9H2. So this kind of reaction takes place when if washing soda is exposed to air. It is extremely important reaction. What is the action of air on washing soda? So it loses its water molecules and it converts into this form. It loses its 9 molecules. Next is, what is the action of heat? Second is action of heat. If we heat this, then in case of heating, although other salts, if we heat them, so they decompose. But if due to the process of evaporation, water gets evaporated. So now in this case, washing soda does not decompose, it loses its water molecules. Then it loses it again, Na2CO3 10H2O, and on heating it becomes Na2CO3 plus 10H2O. As you can see, it becomes anhydrous. Anhydrous, it means it becomes dry salt. It loses all its water molecules by the action of heat. Now next is, what is the action of acid? Now third is action of acid. action of acid on sodium hydrogen carbonate. Now if we, I'll just write here Na2CO3 plus 2HCl, it results in the formation of NaCl plus H2O plus CO2. So these are the effects of different substances on washing soda. So first, if it exposed in air, it loses 9 of its molecules of water. If we provide heat, it becomes anhydrous sodium carbonate. And if it reacts with acid, it results in the formation of sodium chloride, water, and carbon dioxide gases involved. So these are the effects of air, heat, and acid on washing soda. Now, what kind of question can come in exam? First is, what happened to the crystals of washing soda when exposed to air? So, as I told you, when we leave washing soda or when we expose the washing soda in air, it loses its water molecules, 9 of its water molecules, and this is the reaction. And this process is known as efflorescence. When it is removing 9 of its molecules, and so this is known as efflorescence. Another very important term. So this phenomena is known as efflorescence. When salt reacts with air and loses its water molecules, it becomes efflorescence. So this reaction you need to write, which I have already discussed with you. Now next is, what is the chemical name of washing soda? Name 3 raw materials used in the in making washing soda by solvay process. Now look here, it is mentioned solvay process. So chemical name of washing soda is sodium carbonate decahydrate, and question can come on this also. Why we call it decahydrate? Due to the presence of 10 molecules of water, we call it decahydrate. And the raw materials which are involved in its preparation are ammonia, brine, and limestone. These are the raw materials which are used in making of washing soda by solvay process. So this is extremely important question. Both questions are extremely important. What are the uses of sodium carbonate? This sodium carbonate is used for cleaning clothes, which we are using in our daily life as a detergent. It is used in making washing powder and detergent cakes. It removes the permanent hardness, and it is used in the manufacture of glass and paper. Now, few more terms are associated with this what when we prepare it. Before that, this table is extremely important. These are certain salts with their chemical name and common name and their formula and their uses. First is washing soda, which I have just discussed. Chemical name is sodium carbonate decahydrate. This is a summary of all the salts which I have discussed so far, except this, which I am going to discuss now. Chemical formula is Na2CO3 10H2O. It is used in the manufacture of borax, caustic soda, softening of hard water, used in glass and paper industries, in cleaning clothes. So you can write any uses. And baking soda, that is sodium hydrogen carbonate, NaHCO3, used as an antacid ingredient of baking powder. Because when we prepare baking powder, we use this baking soda when we heat it, if you remember. Now bleaching powder, chemical name is calcium oxychloride, and it is used to bleach clothes as an oxidizing agent. Due to the presence of chlorine, we use as a disinfectant and in the manufacture of chloroform. So this plaster of Paris, I will discuss just now. What type of questions can come in the exam? Like, what is the common name of the compound CaOCl2? And the common name of CaOCl2 is bleaching powder, and chemical name is calcium oxychloride. So you need to learn all chemical names, common names, their formulas, their preparation and uses. Then second is, name the substance which on treatment with chlorine yields bleaching powder. Now slate lime yields bleaching powder in treatment with chlorine. And the answer is calcium hydroxide. This reaction we have already discussed. Now next is, name the sodium compound which is used for softening hard water. And the compound which is used for softening hard water is sodium carbonate or sodium hydrogen carbonate, which is water. Okay, so these are the questions according to the exam point of view. They are extremely important. Next is, write the chemical formula of washing soda and baking soda. Which one of these two is an ingredient of antacid, and how does it provide relief in stomachache? As I told you, washing soda, its name is sodium carbonate, Na2CO3, or we can write sodium carbonate decahydrate. And baking powder is, baking soda is sodium hydrogen carbonate, which is used as an antacid, being basic in nature. It is made up of strong base and weak acid. That's why we call it basic salt. And due to this basic nature, it neutralizes the effect of acid produced in our stomach. So that's why it reduces the acidity of our stomach. Now next is the water of crystallization. See, as I told you, many salts, they contain some water molecules. When salts contain water molecules in a fixed amount, so we call them water of crystallization. So when they are known as hydrated salts, and the water molecule present in those salts is known as water of crystallization. The presence of water in a salt is known as water of crystallization, and those kind of salts are known as hydrated salt. And if water is not present in salt, so we call it anhydrous salts. We call them anhydrous salts. So the difference between hydrated and anhydrous salts is hydrated salts. It means they contain water molecules, and anhydrous salts, they do not contain water molecules. If we heat some salt, they lose their water molecules and they can be converted into anhydrous. Or we can convert anhydrous salt into hydrated salt by adding water into it. So vice versa. So we can convert hydrated into anhydrous also, or anhydrous into hydrated also. If we remove water, it becomes anhydrous. If we add water, it becomes hydrated salt. And the presence of water molecule is known as water of crystallization. An example is copper sulfate. When we heat copper sulfate, so I'll just explain one activity to you. Just take a test tube. In this, we'll take copper sulfate. Here it contains water molecules. As you can see here it contains water molecules. So if copper sulfate and just add some water into it, now it becomes hydrated salt, and then provide heat to this with the help of clamp. Now if we provide heat, this water starts evaporating, and this water evaporates and collects here in the form of water vapors. So if water is removing from it, even water is releasing, we have taken copper sulfate pentahydrate, which contains 5 molecules of water. And when we are heating this copper sulfate pentahydrate, and when we provide heat to it, we can see that water droplets start appearing on the test tubes. So this shows that it contains some water. And when water evaporates, its color changes. Earlier it was blue. Now its color changes to white. And copper sulfate, which is left behind here, this is copper sulfate, which is left behind here, its color changes to white. And this type of copper sulfate is known as anhydrous. And when we collect this copper sulfate, which is white in color, and if we add some water into it, again it becomes blue in color. By adding water to anhydrous copper sulfate, it again becomes hydrated copper sulfate and it becomes blue in color. Earlier it was white, now it is blue in color. So this activity shows that we can easily convert hydrated salt into anhydrous and anhydrous converted into hydrous, and salts contain water molecule. And this is known as water of crystallization. Presence of water in a salt is known as water of crystallization. Now next is plaster of Paris of POP. This plaster of Paris is prepared from gypsum. It is prepared from gypsum. Now gypsum, the chemical name of gypsum is calcium sulfate dihydrate. Again hydrate, it means it contains two molecules of water. Di means two, hydrate means water. So when calcium sulfate combines with two molecules of water, it becomes calcium sulfate dihydrate, which is a gypsum. It is extremely important question. How can you prepare POP, a plaster of Paris, from gypsum? So this plaster of Paris is prepared from gypsum when it is heated at 373 Kelvin. So when we heat gypsum at 373 Kelvin, it loses its 3/4 of its water molecules due to the process of water of crystallization and forms POP. As you can see here, when we heat gypsum, it loses 3/4 of its water molecules, and this POP is a white color substance which contains only half molecules of water. And that's why we call it calcium sulfate hemihydrate. Hemi means half. It contains only half molecule of water. So this is how we prepare POP from gypsum. And this white colored substance which we get, this is known as POP, and this POP we use in this fracture, in making statues. Now, what are the properties of this white colored substance? When combined with water, it generates heat and hardens into a porous mass, and it liberates lots of heat. See, when we mix this POP with water, it liberates heat. It's an exothermic reaction. And due to this, the container in which we are keeping this POP, when we add water, that container also becomes hot due to the liberation of heat. You have observed when laborers come in your home to paint your house, when they are using POP for making some designs in your home, so they'll add POP, they'll add some water into POP, it becomes hard. It becomes hard mass-like structure, and it releases heat. This is an exothermic reaction. And during the setting process, the volume of this white colored substance expands. So it entirely fills the mold and leaves a clear impression. It means that's why we use POP in making statues. The tendency or the property of the POP to settle, and when it settles, it expands. So it takes the shape of the mold in which we are pouring this POP powder. Now, after this, where we are using this POP, as I told you, we use in making sculptures. In dentists, we use it for surgical instruments. We make some toys also. In surgery, for setting broken or shattered bones, when fracture is there, the doctor uses this POP, that white color substance, on which they apply some bandage so that the bones regain its position. Because when they mix this POP with water, it settles. It becomes hard substance. And in the creation of blackboard chalks and statues in the construction field also, we are using this POP. Now these are the uses of POP. And what kind of question can come in exam? Like, what is POP or plaster of Paris chemically known as? How is it prepared? List its two important uses. As I told you, POP is known as calcium sulfate hemihydrate. Hemi means half. Our question can come in this way also. Why we call POP as a hemihydrate? It is due to the presence of half molecules of water. We call it hemihydrate. And it is prepared by heating gypsum at 373 Kelvin. So when you are writing this reaction, remember, write the correct temperature. Only at this temperature it can convert. If we increase the temperature, it solidifies. So at this temperature only, if we heat gypsum, it forms POP and it releases 3 by 2 or 3 by 2 molecules of water. And it is used in preparing chalks, casts and molds, or used by dentists, or in case of fractures, in construction field, surgical instruments. So these are the uses. You can write any uses of your choice. Now next is how we prepare gypsum. As I told you, POP is prepared from gypsum. But how this gypsum is prepared? See, this calcium sulfate dihydrate, when we heat at 373 Kelvin, it results in the formation of calcium sulfate semihydrate, which is a POP. This is POP, or we call it plaster of Paris. Now, if we add this POP with 1.5 molecules of water, if we add this POP with 1.5 molecules of water, it results in the formation of gypsum. So this is how we get gypsum again from POP. And this gypsum is white or colorless or green color, and we use different shades of gypsum also. This gypsum is in different color due to the presence of the impurities into it. Now when we allow this POP to settle, it converts into this gypsum if we add some molecules of water into it. Now it has a tendency to reabsorb. So when POP reabsorbs water, it reforms gypsum. So POP can be formed by gypsum, or gypsum can also be formed by POP. Now what are the uses of gypsum? We use gypsum in construction buildings, in making pottery and molds, in dental appliances, manufacture of POP, in soil hardening material, in cement, filler ingredient in many foods, and gypsum is used in manufacture of cement, soil conditioning. So these are the uses of gypsum. We can use as an ornamental purposes also. Gypsum can also be used in fertilizers, and it is used in the preparation of POP. So these are the uses of gypsum. Now what type of question can come in exam? What do you mean by water of crystallization of a substance? Describe an activity to show that blue color copper sulfate crystals contain water of crystallization. Just now I have explained this activity to you. Water of crystallization means when water is present in salt, that process is known as water of crystallization. And how can we prove it? With the help of this activity, like in a test tube, when you take copper sulfate crystals which contain some water into it, which is blue in color, These copper sulfates are blue in color, and when we provide heat, so the water molecule starts evaporating and collect in the form of water vapors in the test tube, which leaves behind white color anhydrous copper sulfate. So this activity shows that copper sulfate contains some amount of water. And when we add water into this anhydrous, it again converts into blue color. So with the help of this, we can show that copper sulfate contains water of crystallization. So now I hope this chapter is clear to you, and in next class I will discuss important questions according to the exam point of view from this chapter. So before that, please go through the entire chapter thoroughly, revise each and every topic in detail, so that whatever questions I discuss with you, it will be clear to you. So till here, now our chapter is finished, and these are the questions which can be asked in exam. I'll discuss more questions related to this chapter. So today we have covered this baking soda, baking powder, water of crystallization, washing soda, POP, and gypsum. So these topics I have covered today. Their preparation, their uses, and what are their properties. So go through all these salts. These are extremely important types of salts, and in exam question can definitely come. So this table is also extremely important. Go through this table, which is a summary of all the salts: washing soda, baking soda, bleaching powder, POP, and the chemical name, formulas, and uses. So learn this table as well. So these topics we have covered so far today. And solvay process is extremely important. What is brine? So these are 1 mark questions. What is solvay process? Or what is chloralkali process? Brine? And what is the difference between anhydrous and hydrated salt? Or how can we prepare the washing soda? So these are the questions, frequently asked questions. Then apart from this, why baking soda is used as an antacid, and or which acid we use to remove the bitterness of this food when we add baking powder into it, or why we add tartaric acid. So these all are reasoning questions. Just go through these topics which I have explained to you,